Good morning, my dear students. Unit 1 Introduction, Unit 2 Transients are completed. Now we started Unit 3 Fundamentals of Harmonics and Applied of Harmonics. So, what are the effects of harmonics in power system? This is a very important concept. So, while coming to the Unit 3, which is the fundamentals of harmonics and applied harmonics. Unit 3 contains harmonic distortion. What is the harmonic distortion? Voltage versus current distortion. Harmonic versus transients. Power system quality under non-sinusoidal condition. Harmonic indices. Harmonic sources from commercial load. Harmonic sources from industrial loads. Applied harmonics, that means effect of harmonics. Harmonic distortion evaluation. Principles of controlling harmonics. Devices for controlling harmonic distortion. What are the devices for control the harmonics? What are the devices? That is a filters. So harmonic distortion. What is the meant by harmonic distortion? Means harmonic distortion is caused by non-linear devices. So which are the non-linear devices? Means diodes, thyristors, GTOs having the non-linear devices in the power system. The main cause of harmonic distortion is a non-linear load. A non-linear device is one in which the current is not proportional to the applied voltage. Current is not proportional to the applied voltage. A periodic distorted waveform can be expressed as a sum of sinusoidals in which the frequency of each sinusoidal is an integer multiple of the fundamental frequency of the distorted wave. This multiple is called harmonic of the fundamentals. Total harmonic distortion is a term used to describe the net deviation of nonlinear waveform from ideal sine waveform characteristics. Total harmonic distortion is the ratio between the RMS value of the harmonics and the RMS value of the fundamental. So the total harmonic distortion is the ratio between RMS value of the harmonic by RMS value of the fundamental. So IH is equal to the root of I2 square, I3 square, I4 square, I5 square, IC square plus I7 square plus and so on. So the total harmonic distortion is a fundamental harmonic content by fundamental current. That is a I1 into 100% total harmonic distortion. So while coming to the current distortion caused by non-linear resistance. If a sinusoidal waveform is applied to a non-linear resistance, what happens? Please see. If a sinusoidal waveform applied to the non-linear resistor, because of the non-linear resistor, so the waveform will be changed just like us. That contains multiples of harmonics because of the non-linear resistor. Because the voltage and current is not proportional to in non-linear resistor. So this is a current distortion caused by non-linear resistance. What causes harmonics? So the causes of harmonics are power electronic equipment VFDs. VFD stands for variable frequency drives. The variable frequency drive causes harmonics. Electronically commutated motors, that is the EC motors, electronically commutated motors. Commutation is a turn-off procedure. Rectifiers, computers, LED lights, EV chargers, arcing devices, arc furnaces, fluorescent lights. Arcing devices are the welders, arc furnaces, fluorescent lights, etc. Iron saturating devices, that is the transformers. So normally the commutation is a process. So in DC motors, that is a brush shifting position. So brush shifting position in DC motor. So that is controlled by electronically causes, there is a harmonics. So please observe the harmonic content waveform. That is not an exact sinusoidal, that is just like S. Please observe the waveform. Because of a non-linear resistors, the harmonic content causes waveform will be changes just like S. So f of x is equal to sine of x plus sine 5x by 5. So what are the sources of harmonics? Sources of harmonics are very important. What are the sources of harmonics? That will be divided into three categories. First one is a fast switching of power electronic devices. Fast switching means by using MOSFET, GTOs, thyristors. Next one is a conventional sources. Conventional sources causes also a harmonics. Modern electronic equipment causes also a harmonics. So what are the fast switching of power electronic devices means? That is a controlled rectifiers, uncontrolled rectifiers, whether that is used thyristors or GTOs or diodes. So that is a rectifiers. Next, cycloconverters, inverters, converters. So all converters causes also a harmonics. Conventional sources are electrical rotating machines, reactors, transformers causes harmonics. Modern electronic equipment means arc furnaces, variable speed driver, fluorescent lamp, printers, microwave ovens, air conditioners, personal computer, television, uninterruptible power supply, that is nothing but UPS. These all are the causes for harmonics. The harmonic content means the multiple of frequency. The waveform contains a multiple of frequency causes the waveform not exact sinusoidal, that is a some distortion in waveform, in entire waveform. Voltage versus current distortion. So the voltage waveform even at the point of generation contains a small amount of distortion due to non-uniformity or non-uniformity, the excitation, magnetic field and discrete spatial distribution of coils around the generator stator slots. The distortion at the point of generation is usually very low, that is less than 1.0%. Many of the loads installed in present days power systems are harmonic current generators. Combined with the impedance of the electrical system, the loads also produce harmonic voltages. The nonlinear loads may therefore be viewed as both harmonic current generators and harmonic voltage generators. So harmonic contains in both voltage and also currents. Both voltage and also currents. Adjustable speed drives, that is the ASDs, perform speed control function very efficiently. ASDs are generated for large harmonics because of the sudden changes in the frequency causes harmonics, currents. Fluorescent lights use less electric energy for the same light output as incandescent light bulb produces substantial harmonic currents in the process. The explosion of personal computer use has resulted in harmonic current proliferation. So what are the voltage versus current harmonics? The voltage versus current harmonic. The word harmonic is often used by itself without further qualification. For example, it is common to hear that an adjustable speed drive or an induction furnace cannot operate properly because of harmonics. The main cause of harmonics, the induction furnace not operated properly because of the harmonics. The induction furnace, the efficiency also decreases, that not perform it won't efficiency. So these are main important phenomena. So adjustable speed drive or an induction furnace cannot operate properly because of harmonics. What does that mean? Generally, it could mean one of the following three things. First one is the harmonic voltages are too great, the voltage too distorted for the control to properly determine firing angles. The firing angles cannot operate it properly because of the harmonics. If you give the firing angle 30 degrees, that exactly 30 degrees not turn on the rectified circuit or inverter circuit. Whatever the circuit, the firing angle is mal-operation because of harmonics. Second one is the harmonic currents are too great for the capacity of some devices in the power supply system, such as transformer, and the machine must be operated at a lower than rated power. The harmonic voltages are too great because the harmonic current produced by the device are too great for the given system condition. So current versus voltage harmonics. So the harmonic current flowing through the AC power system impedance result in harmonic voltage drop at the load bus and along the feeder. If you observe the diagram, this is a sinusoidal power supply system, that is a generating system. That is a purely non-linear devices, that is a voltage drop, distorted load current. Whenever the supply is coming to from the source to load end, because of this non-linear devices, this non-linear devices, the voltage, distorted voltage will appear across the load. Harmonic versus transients. So harmonic versus transients, please observe carefully. What is the difference between harmonics and the transients? Normally the transients are present only few cycles in a system, very few cycles, that is a 3 to 4 or 4 to 5, very less cycles present in transients, but that abnormal voltage is rises in that cycles. But harmonics present in entire waveform. So the harmonics occur in the steady state and are integer multiple of the fundamental frequency. But the transients, there are the natural frequencies of the system. Please observe carefully. Harmonic is a multiple of the fundamental frequency. There are the natural frequencies of the system. At the time of the switching operation, these frequencies have no relation to the system fundamental frequency. So whatever the transients are there, the frequency not changes. The frequency is a constant. But in harmonic contents, the frequency, multiple of frequency presented in waveform. The waveform distortion that produces the harmonic is present continually or at least for several seconds. Transients are usually dissipated within few cycles. This is the main difference. Transients present very few cycles, but the harmonics are present in several seconds in a system.